Hello everyone, welcome to the class of Moment of Force. Now this topic is one of the most important topic of physics if we talk about your board exams as it comes for up to 5 marks. And mostly the numericals come from this topic. So we will be solving many numericals in this video. Don't worry, you'll have a practice for that. But before that, we'll study the concept of moment of force, like on what all things moment of force depends. Now, trust me, you won't be bored because this has many applications in our daily life. You people are even doing it in your day-to-day life. So it's very interesting. Let's start. Moment of force is also known as turning effect of force. So by the word turning effect, you can understand that we are talking about turning something by applying force to it. So, moment of force is the rotational effect of force. The definition itself says that moment of force is the rotational effect of force. Now, what does that mean? It means that whenever you apply force to a body which is hinged or pivoted, like it allows rotation. So, whenever you apply force on the free end, like anywhere, on this beam, it rotates this body. So now, on what all things this moment of force depend? What do you think? On what all things it might depend? The first factor is magnitude of force. That is how much force you are applying. And the second is the perpendicular distance from the force to the axis of rotation. That is this, because you are rotating it about this pivot. So distance between the force and the axis of rotation. So two things on which your moment of force depend is the force and the perpendicular distance. Okay, now let's have a look on formula of moment of force. So moment of force formula is, as it depends on two things, that is force and the distance. So the formula is just force into the distance. So now here we can see from the formula that it is directly proportional to both force and the distance. That means it will increase with the increase of both force and distance. Now let's understand this by an example. This is your wrench or spanner which we use for a nut bolt. Now let's try to understand moment of force by a wrench. Now what was formula for a moment of force? That is force into distance. Okay, now let's try to understand what if I apply a force on this first wrench 5 Newton at a distance of 2 meter from the axis of rotation. Like this axis of rotation passes through O. So what will be my moment generated? Like how much will be the turning effect? Will be force, that is 5 Newton, into distance, that is 2 meter. So my answer will be 10. Okay, now what will be your unit for moment of force? What is your SI unit for force? Newton. And what is your SI unit for distance? Meter. So unit of your moment will be Newton meter. Yeah. Okay. Now if I want to increase this moment without changing the distance at which I'm applying. So the only way is by increasing the force. So if I'm applying suppose 7 Newton, if I'm applying 7 Newton at the same distance, the moment will increase. Yeah, so we can see the moment increases even when we increase force. So now, what if I don't want to increase the force which I'm applying? That is 5 Newton, but I want my moment to increase. So what can I do? I can increase the second term on which my moment of force depends. That is the distance of force from the axis of rotation. So here in case 2, what I have done is the force was 5 Newton, but I have increased the distance between my axis of rotation and force, that is now 5 meter. Now what will be my moment for this B? It will be 5 into 5, that is 25 Newton meter. What do you understand by the two example? That is moment A, when I was applying 5 Newton at 2 meter distance, it gave me only 10 Newton meter rotation. But when I applied the same force at 5 meter distance, like I got the moment more than the double. So from this we can understand that when we want more moment, that is like want more turning effect, what can we do is we can increase the distance so that even with less force, like we don't even have to put much effort and we will get more turning effect. So this is the concept behind major things we do in our daily life, like as simple as opening door. Yeah, so we will learn about the application. Let's see some more applications of moment of force. Now, these are some of the examples of moment of force in our daily life. This is a wrench which we use for bolts. Now, usually arms of these wrench are longer so that we can have more turning effect with less force. This is your stone of hand flour grinder. Where is the handle provided? It is provided near the rim so that we can have maximum distance from axis of rotation. And we know when these maximum moment produced is maximum and it is easier for us to grind with less force. Now this is a normal door which we all have in our houses. Where is the handle provided? Near the free end. Now in this case, this hinge acts as an axis of rotation and we have the handle near the free end so that we can have maximum D. And we all know when D is maximum, then even when with less force, we can have more turning effect, that is more moment. What would have happened if the handle would have been closer to the hinge? It would take us more force to open a normal door, and we don't want that. Like, we don't want to put that extra effort in doing something as simple as opening a door. Okay, now this is your seesaw. In seesaw, this thing acts like a pivot. Now, in your seesaw, we know where is the seat provided? Near the ends, so that you can have maximum distance from the pivot, so that you can have maximum moment of force and you can have an easy play. Next time, like see, this girl is sitting somewhere closer to the pivot as compared to the boy. So next time, don't do this. Like sit near and let your friend sit somewhere closer and let him be in air. Now let's see sign convention of moment of force. Now we know moment of force is a vector quantity. Now what do you mean by vector quantity? That it has both magnitude and direction. Now what kind of direction? As it is a turning effect, so there are two directions, that is anti-clockwise and clockwise. Now let's first see what is clockwise. The word itself says clockwise, so in the direction of clock. That is this direction. This is how your clock moves. And anti-clockwise means in the opposite direction of your clock, that is in this direction. Now let's see it on this beam, which is on a fulcrum. When I am applying force on this end, how will this beam bend? It will bend something like this. So to this moment, we say clockwise moment as it is moving in a clockwise direction. For an anti-clockwise moment, when we apply a force on this side, how it will move something like this. This is known as anti-clockwise moment. Now there are some sign convention we take for it. For anti-clockwise, we always take it as positive. There is no reason behind it, like we are just taking it. You have to take the same. Don't change this. Always have it clockwise negative, anti-clockwise positive. Remember one, anticlockwise positive, like you'll remember the other. Now, what do you mean by equilibrium or balance condition? It means that there is no change. Now, how will there be no change when a force is applied? So, we can say when the anti-clockwise moment is equal to the clockwise moment, there will be no change. Like this beam will remain horizontal if both the moment are equal, as they both will try to cancel each other. Their sum will be zero, or we can say they'll be equal. Let's understand equilibrium by this condition. Here there is a 20 Newton force acting on side A and 30 Newton force acting on side B. Now let's calculate how much moment is produced by the force 20 Newton and how much moment is produced by this force, that is 30 Newton. So we can see this 20 Newton will produce an anti-clockwise moment, that is a moment going in this direction. So our anti-clockwise moment is force into distance from the pivot. What is the force? Force is 20 Newton and the distance is 12. That is 240 Newton meter. Now what is the clockwise moment? Now this force 30 Newton is trying to rotate this beam in this direction, that is clockwise direction. So our clockwise moment is, now sign convention, yeah, don't forget to put a sign convention. For anti-clockwise it is positive. Always put sign convention. It is not like your maths. Like if it is plus, we won't be putting it. It's understandable. It's not. In this topic, you have to put. If it is anti-clockwise, put plus. If it is clockwise, put minus. F into D. Now, force in this case is 30 and distance from the fulcrum is 8. Okay. So again, this is 240 Newton meter, but this sign convention is negative. So it is minus. So here we can see AM plus CM. What is AM plus CM? It will be 0. That is plus 240 minus 240. So our beam will be in a state of equilibrium. That is, it will remain horizontal. There won't be any change. Yeah, this is what equilibrium means. Now let's start solving some board question. The first, the easiest one, SI unit of moment is, we know it's Newton meter. Fine. Yeah, let's go on next question. Our next question is, if center of gravity of a meter scale of a mass 80 gram lies at 45 centimeter mark, then which one of the following diagram will show the balanced position of the scale? Okay, so they are saying that this scale is balanced, that is, it is in equilibrium. Now, let's read the starting lines again. Center of gravity of a meter scale. Now, what do you mean by meter scale? Ki the scale is of 1 meter, or you can say 100 centimeter. Now, they are saying that the weight of this scale is at 45 centimeter mark. So, from 0, it is somewhere here at 45 mark. And what is that weight? It is 80 gram. And we know weight always acts downward. So there is 80 gram force, that is its weight acting downwards at 45 mark. Now they are asking us which of the diagram is balanced. Let's start calculating. What is the criteria for balanced condition? We know according to equilibrium, moment of equilibrium condition, we know anti-clockwise moment is always equal to clockwise moment. Now in this case, this 80 gram force is producing an anti-clockwise moment. So force into distance. Now what is the distance between the 60 and 45? 60 minus 45? that is 15. 15 centimeter, like 60 minus 45, that is 15 centimeter. Now this side, now we don't know this force, huh? Like don't take, let's take this as x. Let's take this as x. So the force we don't know. The distance is common for all the three. So that is 100 minus 60, that is 40. X into 40. Let's find out this x. Bring that 40 on this side. 80 into 15. Yeah, 4 ones are 4, 4 twos are 8. Okay, so our force is 30. So which one is balance? This one is balance, this third one. Okay, our next question. This is for 3 marks. The adjacent diagram shows a wheel of diameter 40 centimeter fixed on a wall capable of rotating around its center O. If the wheel rotates in anti-clockwise direction, then so now they have already said us कि it is going to move in anti-clockwise direction. Fine. Now first question is calculate clockwise moment. Who is producing clockwise moment in this? This 100-gram force is trying to rotate this wheel in clockwise direction. So let's calculate that clockwise moment is this force, that is 100 gram, into this distance from O. Now we know diameter is 40, like from this to this is 40. So what will be the radius? Radius is half of diameter, so that is 40 by 2. So that is 20. So 100 into 20 is 2000. So we have 2000 gram force centimeter. It's not Newton. Gram 4 centimeter. Now the next question B is state whether X is 100 gram, less than 100 or more than 100. So here in the question, okay, let's see first. Okay, here we can see that X is closer to O as compared to this 100 gram force. 100 was like at the distance R, radius, but this is somewhere less than R. So definitely even if it is 100, it will provide less moment as compared to this 100 force. So in this case, so it will never be able to rotate this wheel in anti-clockwise direction. But in the question, they are saying the wheel is rotating in anti-clockwise direction. So for this moment to be maximum, or we can say more than this clockwise moment, this force has to be more than 100. Only then it will provide an anticlockwise moment more than this 100 force. So the answer is X should be greater than 100 gram force. So next they're asking you give reason for your answer. So you can just say that as X is closer to O as compared to 100 gram force. So to rotate the wheel in anticlockwise direction, it has to be more so that its product with the distance is more than your 2000 gram force. Okay, next question is this. So they have shown you some forces at a certain distance from point O. We have to calculate their moment. So now first tell me like in which direction the moment is acting. So in this A is in this direction. That is your clockwise direction. Even B is in clockwise direction. But your C is in anti-clockwise direction. Yeah. So C will be plus, others will be minus. Next, they're asking you the first question in this is name the force which produces maximum moment. What is your MA? FA into DA. What is FA? 10 Newton. And dA is distance of A from the center O, that is 4 centimeter. So our moment is 40 Newton centimeter. That is minus because it is in clockwise direction. What is MB? It is 12 into 2.5. That is 30 Newton centimeter. Again, this is negative because it is in clockwise direction. Next is your moment of C. That is force is 12 and distance is 2. So the moment is 24 Newton centimeter. Now it is in anti-clockwise direction, so it will be plus. The next question B is calculate this moment in SI unit. Okay, so they're asking you to convert it into SI unit. Okay, let's find first the final, or you can say resultant momentum. So resultant is add all of them. Resultant is MA plus MB plus MC. MA is minus 40, MB is minus 30, MC is plus 24. Calculate it, you'll get answer as minus 46 Newton centimeter. But then they have asked you to get answer as an SI unit. So SI unit, you have to divide it by 100. So the answer will be minus 0.46 Newton meter, the resultant moment. So this is your answer. Okay, so our next question is, if the moment of force about center of a wheel O is 6 Newton, so they have already told us moment about O is 6 Newton meter. Write the givens first. Calculate moment of force F about A. So they want you to calculate MA. Fine. Okay, now what is MO equal to? MO equal to the force applied into the distance. Let's take this point as B. So OB. Now F is 20, MO is 6, and OB we will find it out. So OB is equal to 6 divided by 20. Fine. Leave it as it is. Now for MA, what all things we need? MA is equal to force, but this time what is the distance between the force and the axis of rotation? They are asking you about A. So about this. So the distance between force and axis of rotation is this. So it is AB. That is your diameter. So diameter OB was radius, diameter will be 2 times radius. So it is 2 times OB. Now force 20, again the same. 2 times OB. OB we just calculated 6 by 20. 20 gets cancelled. 6 2s are 12. So 12 Newton meter is the answer. So the moment produced about A with the force, same force 20 Newton is 12 Newton meter. If it is an MCQ, you can directly calculate that the same force will produce double moment if the distance has been doubled. Yeah. Okay, that was the last question for this video. But now I want you people to try this sum on your own. Please solve it. If you have any doubt, comment down. And even if you get the correct answer, please comment down. I'll pin your answer. Yeah. Yeah. Thank you. Bye.